So we are live on LinkedIn as well. Shab on our side will be paying attention to questions across, I think we're on Twitter as well, perhaps, but Shab will be taking questions from all the different places so that you can, yeah, we'll make sure we answer them. There's also a Q&A function in Zoom, which we'll be using throughout the chat. If you have any questions that come up, just throw them there and I will be happy to answer them. So we still have a lot of people streaming in, so we'll give it a couple more minutes. Awesome. Great, should be, yeah, let's give it till 8:05 our time. Cool. I think the velocity of people joining is starting to slow down a bit, which is good. It means that we're starting to get to quorum. So why don't we kick it off? I'll pass it off to Shab to Makiko rather, to give a quick introduction on what we'll be talking about today.
Hey everyone, my name is Makiko. I hope everyone is having a great day. So like Simba mentioned, today we're going to be talking about feature store usage patterns. So in prior webinars for Featureform, we've talked about, what a virtual feature store is. We've talked about how it can fit into the data science workflow. But, a lot of companies, for a variety of reasons, they really struggle with crossing the chasm from an individual data scientist using a feature store for their own workflow to how do you enable effective usage of feature stores at like an enterprise and organizational level to actually get those returns and to get the collaboration and documentation that a lot of folks promise. So today's webinar it's really going to be more about like the theory and like the practice of feature stores. But yeah, we're really excited for you guys to join us. Yeah, so my name is Makiko. Right now you can't see my face, but I can see all of you. Just a function of Zoom, folks. But that's my face right there. I look the same in real life. I'm head of MLOps at Featureform. The charismatic dude that you have there is Simba. He's founder and CEO of Featureform, smartest brain on the block when it comes to feature stores. So I'm personally also very excited to learn more about how we make that transition.
Oh, I'm muted. Great. Thanks, Makiko. We'll hop right in, like Makiko said. Our goals today. I want to, when you leave this webinar, you should have a clean understanding of how at least one way to think about the feature model lifecycle end to end, to a way to think about how team dynamics, collaboration, stakeholders change as teams go from having a single data scientist to kind of a full-on enterprise data science function. And then we'll also explain how feature stores work, how they become kind of this interface for interacting with data across all those different stages of company. So let's jump right in. Let's first talk about the phases of the model lifecycle. There's three. There's the data cycle, the feature engineering cycle, the model and training cycle, and evaluation. So kind of the model part. And there's also the production part, which you can separate out to a 4th step, or it kind of fits into the 3rd step of it. The first step, like I said, is the data cycle. The data cycle is everything from gathering your sources, which sounds easy, but I'm sure, as many of you have probably dealt with, can be a very long and tedious thing. Hey, where is this data? How do I get access to it? And once you have it, you need to understand it. It's unfortunate that most of the time as data scientists, when we get data, we spend, it's messed up. There's all sorts of like things that we need to clean. And a lot of those rough edges around the data sets are not even documented. So we even have to go and figure out what's wrong with it, analyze it, understand it, and get it to a form where we feel comfortable that the data set is accurate and correct, and it kind of follows the schema, it's formatted correctly, etc. Once we're there and we have kind of the raw data, then we get to the feature engineering cycle. In the feature engineering cycle, we take that cleaned up data set we've created and we start actually doing machine learning on it. Like we start actually taking columns. For example, you might have a raw data set, which is, let's say you're Spotify, you have user listens. You take in the raw data, maybe it's from a Kafka stream, maybe it's in an S3 bucket, and you start by just maybe normalizing the data a bit, cleaning it up, getting a data set, which is the raw listens per user. So it's like, kind of a stream of user song listens. Once you have that, you're going to want to come up with features. Those features can be things like the favorites, a user's favorite song in the last 30 days. It could be their top playlist this week. It could be their top genre of the last year. Those are all potential features. We might normalize those, we might scale those. There's a lot of techniques that we have for feature engineering. But essentially the goal is to build give signal to our models. What we've seen happen and continue to happen is, as data scientists, it used to be very model centric. We'd really focus on the model part of machine learning. And as time has gone on, the models have become more and more commoditized. I think of how many lines of code that you have are actually the model. It's like not many typically, like you'll pip install scikit-learn maybe and like import a model. Even if you're using PyTorch, it's still a pretty dense but small chunk of the code base. Where a lot of the work comes in data science is actually in building and refining our signals to the models, which is feature engineering. So finally, we come up with these features, these labels. Then we get to the training set. Or sorry, yeah, we'll have the training set. Then we get to training the model and working on the model. We'll join together and choose a set of features that we need. We'll join them to our label. So we have a training set. We'll split that training set to a train set, a test set, and perhaps a validation set. We'll train our different models. We'll hyperparameter tune. We'll do some sort of hyperparameter search, kind of really refine the model at this point, using the signal and the features we've created. Now, sometimes we'll kind of go back and forth between this. We'll like go back to the feature cycle, go back to the model cycle, etc. But in general, you're kind of flowing between these modes: data set mode, feature engineering mode, model mode, and finally, there's kind of the production mode. Everything I've talked about before, all that experimentation, often is happening in notebooks. So we have a set of notebooks that are a set of experiments, analyses, tests, maybe a transformation code that you've created. Now you want to get these features in production, you want to get these models in production. I'm going to focus on the features part. Obviously, there's a lot that comes into getting the model production, setting up monitoring, all the other stuff that comes with it. But we need to productionize this stuff as a single data scientist. So we will use perhaps a set of bash scripts. We'll interact with Databricks, we'll interact with Redis, we'll interact with BlobStore. It can get very complex, and it's our job to get all of this stuff, essentially build a training set in production so that we can train our model in prod. And once that's done, we need to take that trained model, serve it, so put it in production somewhere else, and also have a cache of feature values for inference. So again, if you're Spotify, you're making a music recommendation, you need to have, all those features about the user pre-computed. It's not really feasible to go and query through every single user listen that's ever happened every single time you want to make a recommendation. If you're Spotify, you would have Snowflake would be very happy. You'd probably spend a lot of money on them, but otherwise it wouldn't really work. So in this, there's kind of two sets of problems that we see arise. There's what we call the ops problem and the platform problem. As you're building and getting these features in production, you'll end up with a set of notebooks. And if you're anything like me, they'll look like, they'll kind of look like this. You'll have like the new V2, you'll have all these features and training sets and notebooks kind of all over. You'll be copying and pasting between them. You'll try to remember what notebook you ran, what files you ran, what code was run to generate certain training sets, which features are being used here, how were those features created, where was that raw data, has that raw data changed? All those questions we call the ops problem. Like, how was this feature defined? Am I allowed to use it? I mean, this gets more complicated, especially for enterprise, where it becomes, you start to have questions around that. Who owns this? Who's maintaining it? What models are using which features? How do I use this feature? So we call those ops problems. And then there are the platform problems, which in the slide that we had before, it's choosing the right infrastructure to be able to handle your needs. For example, if you are doing a real-time recommender system, you might need a low latency store like Redis to be able to serve those features in near real time. If you're doing, let's say, like, a batch scoring system, but maybe you don't, maybe you can get away with using something else that's maybe cheaper, higher throughput as your inference store. So there's kind of these decisions that must be made of picking the right platform for your needs, especially on the data side, but this obviously applies across the MLS cycle. And it could also include things like, if you're using embeddings, you might need nearest neighbor lookup. You might need to be able to handle streaming data. These are all platform problems. The premise of Featureform is to solve the ops layer and let you choose the platform for you. What that means is all the things we talked about of versioning, managing features, kind of the framework that is used to standardize the feature workflow, that's what Featureform does. The actual compute, like, how do I manage this much data? How do I manage streaming data? How do I serve features in under 10 millisecond latency? You can pick and choose the right platform tools and fit them together to solve those problems for you. And Featureform will give you a standardized interface across all of that. And with that standardized interface comes things like search and discovery, governance, monitoring, and a single API to serve features over in Redis or Cassandra or somewhere else. Same thing for training sets. You can start to mix and match different things. If you have half your data in Postgres and half your data in an S3 using Spark, you can handle that in one interface. You can have all your feature definitions be centralized in one place. And that's kind of the value that Featureform provides. Kind of really zooming into like what that means, like how that looks is like, there's this idea of the feature store, there's monitoring, there's the online serving for inference, there's the training storing, there's all these sources. Featureform kind of provides all of that, and all the kind of things in color in this picture, like the Redis, like Databricks, like Azure, those are all the platform that you can plug in to Featureform. And Featureform will essentially, it's almost like the motherboard that you plug in the compute and the memory and otherwise too. And yeah, like, you can pick the right things for yourself. Like, if you need a certain level of latency, like, again, like we work closely with Redis, we work closely with Cassandra and other tools, and you can pick and choose the right thing for you. Great. So we've talked a lot about the feature lifecycle, the model lifecycle, and I'm going to give a demo quickly of feature form in a moment, and then I'll kind of really get into how this stuff changes as you start thinking about orgs and team size. So one thing I guess I really want to highlight, I've talked a bit about it, is how much feature engineering is just a core piece of that model lifecycle. Like it used to be the case that we would really think about and focus on models. Like the data was pretty static. We'd use, a nice clean data set, and we'd spend time picking and choosing the right model architectures, tuning them, really building the right model for our use case. More and more, the models are getting so good and so general that they essentially become a pip import. So as data scientists, what we're more and more doing is taking our domain knowledge, crossing it with the data we have, and turning that into signal, feature engineering. And it kind of starts to follow Pareto's rule, where data and feature engineering, those two parts of that life cycle I talked about, end up taking up 80% of our time. Maybe like 20% is actually spent on the model part of machine learning. There's all these things we start to think about, like the models and features start existing across notebooks and GitHub and multiple database, multiple buckets. We start thinking about retraining, reliability, versioning, managing definitions, being able to generate a training set the way it was generated before, repeatability. All that stuff is things that we need to take on and become really core to this new kind of paradigm of being more data centric in the ML process. And so I'm going to show you a demo in a moment. I'll leave this on for a second just because feature forms are open source. Everything I'll show you and the notebook we'll go through, this is all stuff that you can go and use yourself. Cool. So I'm going to show a simple example using AWS. And I'll also pause maybe for a second. If anyone has any questions so far, you can feel free to throw them in the Q&A. If you're on LinkedIn or Twitter, putting in, you can also leave a comment or a tweet there, and Shab will be able to catch those. So yeah, feel free to throw questions down as they're relevant, and I'll kind of start setting up the demo as we do that. Cool. So in this simple demo, we're going to create a training data set for a fraud training data set. We're going to be using Dynamo as an inference store. So in production, once the model is in production, we'll be served. We want to serve our features out of Dynamo. That's the platform choice we've taken there. For our raw data is an S3, and we'll be using Spark as an ETL. So we'll use Spark to kind of turn that raw data into all the pieces that we need. And so let's go through that. So feature form is, we have a local mode, which I won't really get into in this chat. We have had webinars about local mode before, so you don't even need any infrastructure. You can use feature form just on your laptop alone. But assuming that you have infrastructure on AWS, let's say, the first step, if you're starting clean, is to register your infrastructure. Like you can register Dynamo, you can register Spark. The next step is to register your sources. So we talked before about there's that data cycle. So it's up to you where you want to kind of start your sources. You can start your sources at the very raw data that hasn't even been cleaned yet. Depending on how your team's set up, sometimes you might want to start with clean data. And so that only the machine learning, the feature engineering lifecycle fits through the feature store. It doesn't really matter. You can pick and choose where you want to start. But the point is that the first thing you need to do is register the sources of feature form. The next step is to register your transformations. So like I kind of showed in that slide, is typically a DAG. Like there's some sort of like set of transformations that are run to take the raw data and turn it into signals, turn it into features. And in this case, we're using Spark. So we might have, a PySpark code like we have here. Feature form itself supports SQL and supports data frames. So if you're using data frames in any way, we likely support what you're using. If you're using SQL, we likely support the SQL database. If you're using, let's say, pandas locally and then using PySpark somewhere else, you can have transformations that use data frames in both. So yeah, you would register your transformation. You essentially take your PySpark code, you wrap it in this function, you specify the inputs, specify a name, you can specify a version, specify an owner, you can give a description, etc. You can start saying, hey, this column is a feature. This feature is stored in Dynamo, like we said. You start declaratively defining and setting up the metadata of all your features, your transformations, etc., that you're doing for machine learning. You can specify your label as well. Then you can join together your labels and features that you need. You can kind of do that feature selection step and really set up the right features and the label to join them with to build a training set. Finally, you apply it. When you apply it, you're sending this data to feature form, the metadata. Feature form will then orchestrate Spark S3 Dynamo. It will handle errors. It will do retries for you. You can set up a schedule so it can run, every hour, whatever. It will do all that for you, and it will also give you a nice UI so that you can look at and understand, what features do you have, how are they defined, where are they stored, like this is in Spark. You can ask questions like, I have an entity called customer, so a concept of a customer. What features do I have associated with customers? So all these things you sort of get, and this is reusable, it's shareable, like other people can look at this, which I'll get into how like team structure works. Yeah, I mean, the whole point of a training set and features, like we said, is to train a model to serve features in production. So how do I use this training set I just defined? Simple. I would specify the training set, like I am down here. I can batch it, I can shuffle it. We have a nice API to allow you to kind of tune the data set, split it, do whatever you need with it. And you can loop through and train your model. If you want to serve for inference, like in production, like out of Dynamo, you can specify a feature like average transaction and an entity. So like, hey, like I want to know average transaction for this user. And that will give you a feature vector that you can use and feed your model in production. So, you probably do that in the notebook like this, but it's still the same concept of you have a nice API where you've defined out a feature, you define out your labels, you define out your transformations, your training sets, etc., and they become usable across production, training, experimentation. You end up with a centralized repository of definitions with metadata, with monitoring, with basic analysis, with search, governance and access control, which I'll get into, etc. So that's kind of the basic. I want to start with like a basic overview of feature form. Obviously, there's a lot more here. But now that we kind of understand the feature lifecycle, the data lifecycle, the model lifecycle, we've now looked at code of like, hey, how does the feature store work? Let's get into how the patterns that we see used, like how feature form gets used from single data science teams all the way up to large enterprises. And like I said, at any point, if you have questions, feel free to throw them in the Q&A. And on LinkedIn, Twitter, you can also ask questions there if you're not on Zoom. Cool. Well, let's get into it. Let's start with the first kind of the MVP data science team. You're the first data scientist to join an organization. Typically, you're brought in to build a specific model. For example, you join a B2C company. You're the first data scientist. Like likely you're building a recommender system. You're joining, let's say, a fintech company. You're probably building a fraud detection model or something similar. There's a lot of these kind of basic models that people just expect to have, and eventually, like we need a data scientist to actually build them. So you get brought in. You're data scientist number one. You look around, you realize that you have zero support on the data science role. It's your job to find the data. You have to go figure out your own infrastructure. You're going to work with you're essentially like working with the software engineers to figure out and get what you need and be able to use it. There's a story we heard of someone who joined as a first data scientist, and they built a notebook, and they found the data, they did everything, we built the notebook, they got the model, it worked for a specific use case or a specific model that they needed. And they're like, great. They told their manager, great, I have the model. Like, I did it, like, job well done. And they're like, yeah, well, cool. How do we use it? Like, how do we, like, it needs to be deployed somewhere and it needs to be monitored. And we need those features in production. And so as the first data scientist, you're kind of truly full stack. You own everything. So where does the feature store fit in? Like, a lot of times when people talk about feature stores, they talk about the sharing and that kind of aspect of feature stores. But in our experience, a lot of people using feature stores when they're literally one data scientist sometimes, they are using the feature store as a repository. It's almost like Git-like thing. But unlike Git, it understands experimentation. It does some level of analysis. It really is easy to plug in and out features in and out of different notebooks. Like, it fits into the data science workflow, which is far more messy than the software engineering workflow, which is typically more of a straight line. Like, what you're building, you kind of build towards it. And data science is a lot of kind of like going in circles and really trying to experiment and figure out, what the right thing to do is. Great. So what's the feature store's value there? Well, it's storing and organizing transformations, the features, the training sets, and a repository that's actually built and understands what a feature is. It's keeping a history of changes. So you can go back and you can understand, how did I build this training set? What were the steps I took to get there? It's kind of like keeping you as a data scientist organized. Like, it's like, and it also allows you, if you're the first data scientist and you're successful, there are more data scientists coming behind you. And it's the worst thing ever. Like, it's hard enough to come as a first data scientist. Coming as a second data scientist has its own set of problems, which is you have to go and find, untitled notebooks that the first data scientist might have on their laptop and try to figure out what's used, what's in production, how is in production, how did you get there, what duct tape exists where, like, where are things breaking? And this sets you up for that. On the productionizing side, this is more about the experimentation. On the productionizing side, it creates one API for feature deployment. Like, you as a data scientist don't have to like Spark submit jobs. You don't have to create tables in Dynamo or hashes in Redis and keep track of those. All that is pushed off to the data store. Retry, scheduling, everything kind of gets handled by this virtual feature store. Monitoring, and that unification. You can kind of have one interface to look at your experimental features, like features you're creating and experimenting with, and features that are actually in production today. It's all in one place. Great. So some of you will probably still be in this bucket. The next bucket that we see is the first team, the first data science team. It's typically, let's call it 5 to 7 data scientists. Generally, each of them is handling or managing about one model. Sometimes it's like a few people working on one model. Sometimes, everyone has like a model and a half. And there's typically a lead, like a tech lead. It could be the person who joined first, could be the person who's more senior. Someone is typically, at that point, you need someone to kind of be a leader, but they're typically also an IC, or not like a full-time people manager. You start to unify the infrastructure, right? Like, it's not like everyone sets up their own Spark cluster anymore, and everyone sets up their own DynamoDB instance. Like, you start being able to share things, but there's no workflow for it. Like, all the sharing is done through like over Slack, essentially. And that tech lead's goal is to, one, provide value, make sure that like the business is seeing value from having a data science team that's this large, but also making sure that the team is reliable and nimble. There'll start to be lots more stakeholders asking for things. Like, marketing needs a model to for this promotion, or product needs a model to decide when to put up a paywall. There's a lot of different things that start coming up. and keeping the team nimble, reliable, making sure that models don't break in production, where when you had one data scientist, they have to really truly manage everything. If you continue to do that and treat every data scientist as a lone wolf, which is usually what happens, those things start to compound. That's like, there's always a model down, because across 7 of you, like chances are something is probably broken right now. In the team workflow, we showed before about single data scientist workflow. The team workflow looks similar in that most people are kind of working on their own model, but you start to see more copy and pasting. You start to see people, reusing other people's notebooks. Maybe someone else kind of adopts a model from a different data scientist. Even though you're sharing the same infrastructure, you likely have your own set of scripts to manage that stuff. You have your own naming schemes. This is like what we typically see in teams that are, 5 to 7 people not using something like Featureform. Well, Featureform, I'll kind of go into a workflow. Let's say we have 2 people, Tim and Carl, that are working together. Tim brings on Featureform. And we'll send these slides after so you can actually read them. I'll just walk you through them. Tim's job is essentially to go and do that notebook I showed you. He's going to set up the providers. He's going to set up the original sources, the transformations, the features, the labels, the training sets, train them all, they'll productionize it. Everything that would look pretty much the same if you were a single data scientist. Now, where the value comes from a team side is if you're Carl, you can look at that UI I talked about, or you can use a CLI. You can see what infrastructure exists. You don't have to go and set that up yourself. You don't have to go figure out the secrets. You don't have to go and see what's scheduled there today. You can start using those other transformations and sources that Tim has already created for you, or just created for himself, actually. And because you have those definitions, you can see which models are using which features. You can onboard faster. You can come up with ideas. You can use features that were created for other use cases, for your use cases. Like if you're doing a fraud detection data set and you're doing like a recommender system, there's some user features which may be useful in both. So in the end, what ends up happening is Tim is productive the same way a single data scientist would be. There's a standard that they're using, there's a framework, there's versioning, there's management, all of the infrastructure, lots of the infrastructure issues are resolved. And for Carl, he's able to quickly onboard, get up to speed, reuse things that Tim built, where it becomes a source of truth of features, transformations, providers, etc. So in the end, you end up with all these data scientists experimenting, productionizing features, and this shared repository, which is useful to all of them individually, but creates compounding value as the team grows. It enhances communication and collaboration. It standardizes workflow, versioning, governance, and coding standards. There's one framework. We're all using the same thing. Think of it like Ruby on Rails. Like if we're all using Ruby on Rails, like at least everything is standardized. If you're all using Featureform, all the feature engineering code definitions, etc., it's all centralized, and you're all using the same framework. So you can kind of understand how features were created. You can see what code was used. You can see where that code is, what's in production, etc. And finally, that reuse and sharing is possible because the definitions themselves are immutable. So, I can use someone else's feature and not worry about it breaking or changing underneath me. Cool. Well, and like I said, at any point, if anyone has any questions, feel free to throw them in Q&A. Otherwise, I'll kind of keep chugging along. You have a team. They've been successful. You're creating business value. You have, 7-ish features in production that are all valuable. All of a sudden, you're getting bombarded by stakeholders. Marketing needs 20 models. Product needs tons of models. So there's finance. Those hacky things and techniques that you use to get your models and features in production that maybe you weren't using Featureform, they start breaking down quickly. Now we're talking about like 15 data scientists. You start having data scientists create features that essentially like the same feature, but in different teams because there's less communication. You have way too many people. At that point, this is typically where we see people spin up platform teams, MLOps teams. You end up with kind of like a director of ML, director of data science, something. And they're managing a set of teams, typically a handful of data science teams, and one platform team. The platform team's goal, like their whole reason for existing, is to standardize the machine learning process, make it so models are more reliable, like things aren't going down. Add some level of visibility so that data scientists can see what other data scientists are doing, kind of management can look down, data science can look up and understand like how things are moving at a larger scale. They're building the platform. This is how company X does machine learning. I'll get into the feature story usage pattern here. It gets kind of more obvious. You have all these different teams. All these teams now have a standard way. Essentially, the platform team will be tasked with building a feature store. Almost always, this is where we see kind of internal feature stores start to spin up. Because like everything we've talked about so far, you will find that, hey, the data part of machine learning is super messy. There's no standards. No one really knows what features are being used where. There are notebooks being passed around over Slack. There's a lot of tribal knowledge. The platform team's goal is to start to fix that and make it more institutional knowledge and build a platform that everyone can use and benefit from. At this point, Featureform's open source. It kind of becomes, this is where we see a lot of people start bringing it in as they start thinking of all the parts of their platform, from model serving to monitoring to feature stores, to experimentation trackers, etc. This is where Featureform starts to get pulled and plugged into larger companies. The final company stage and the final pattern we see at this point, there's a director, and that director has managers, and those managers have teams, but they're still all in one, let's call it triangle of the org chart. There's still one data science silo. Finally, if you work at a Fortune 500, for example, it changes a lot. Now you have many platform teams, because data science teams are starting to get split up. There's not one ML function anymore. There are ML teams everywhere. Different product teams will have, or product orgs will have a data science team. You will end up with deprecated projects. You end up with teams that get reorged out. You have data scientists constantly joining and leaving, because you might have hundreds now, or at least over 100, where the tribal knowledge starts to break down quickly, if that's what you're dependent on. You end up with embedded teams. You might have a single data scientist on one team who kind of looks like what I was explaining before, and then you might have a COE, which is almost like a whole org in itself. And typically at this point, if you're a Fortune 500, governance, regulation, access control to data, all this stuff becomes really, really important. And much to the chagrin of most data scientists, it makes things move really, really slowly, because everything has to be checked. You have a CDO or something. You end up with all these teams. You have teams that are essentially building the same thing in different kind of org charts. There's chatbot team 1 and chatbot team 2. You have product X has a data science team. There's the data eng teams. There's specific teams that their whole role is just to collect web app data. Legal becomes really important. Policy and regulation becomes important. So as a data scientist, how can you be productive in such a messy environment? One thing, I actually just heard this yesterday. I literally added it in the slide just because I loved it. At a sufficiently high scale, everything is just a logistics problem. Everything is just ops. And how we see feature stores get used at the enterprise and the kind of those level and the org level is you start specializing. You start taking these abstractions, the feature, the label, the training set. You build logic on top of it. So you essentially codify your feature lifecycle. I'll give you a few examples here. Let's say you are a data scientist at a health insurance company, and you're working on a specific model that's highly regulated. Every time you get a feature in production, you might need to go through legal. Well, with Featureform, all those policies can be ingrained in the feature store. So you don't have to go figure out, who do I email? How do I get to them? They don't have to be like, hey, like, how do I interface with the data science team? All your workflows, even things like features have to go to dev clusters before they go into prod. You know, these are steps that have to pass. All of those custom workflows can be codified into the feature store. And the feature store becomes the place where truly the feature workflow lives and is defined. Actually, and I think there's a question in Q&A, which is pretty much the same question, which is feature form itself. So the open source version, you can go run it, you can deploy it on Kubernetes. It's relatively straightforward. Everything I'm describing here, the custom lifecycles, access control, governance, all the stuff that comes into play if you're an org or an enterprise, for sure. That is all in, that's kind of the proprietary version of feature form. And the proprietary version of feature form comes with all of that. It's also a managed service. We can manage it on-prem, in your cloud. We can, yeah, wherever you need it, it could run. We can even run across cloud. Feature form, the virtual feature store concept allows us to be very, very flexible in how we run and what we work with. So yeah, there is a managed version of feature form, and the managed version of feature form is one, managed, and two, comes with all these enterprise grade features that if you're a single data scientist, you probably don't care about, honestly. But if you're a Fortune 500, you sure would think a lot about this, because like we said, like, you know, this will seem familiar to you. And it's a logistics problem. And so we solve that. I'll pause here. I wonder if there's any other questions. Feel free to throw them in the Q&A. Great, and this is true of we're also checking LinkedIn and elsewhere if there are any questions. Cool. Yeah, I just have a few more quick points, and then I'll leave it to final Q&A. So just to be really clear about the value of the feature store for the org or the enterprise, you start to get hierarchical search and discovery. You can have team-wide features, individual features, org features, you know, like global features. You can search through those. You can have heterogeneous infrastructure where, you know, one team uses this Spark cluster and this team uses Snowflake, or both. You can get all those cross-functional workflows embedded into the feature store itself. You get the governance, the access control, the audit logs, etc. All of this kind of comes into play, and a lot of this, honestly, is in the enterprise managed version of feature form. But this is kind of the final stage, final pattern we see of feature store usage. Everything I talked about, except for the enterprise things, are open source. You can go use feature form like today. You can go and we have a quick start. You can get up and running from beginning to end in like 10 minutes, 15 minutes maybe. I'm on LinkedIn. If you want to talk or chat or learn more, feel free to get me on LinkedIn. You can email me. I'm also sim@featureform.com. If you have any specific questions for me that I can either answer myself or pass to the right person on my team. Well, thank you all. Again, if there's any questions, feel free to throw them in Q&A. I see one that just came in. Let me take a look at it. So is there a plan to support Azure Data Lake as an offline storage provider? Yeah, actually it's come up. Actually, it's interesting. We've seen probably the most pull for an enterprise version of feature store for Azure customers. So there's a lot of Azure is actually like a top priority for us. We actually prioritize Azure over like Google Cloud, honestly, just because we have way more enterprise users of Azure than we have of Google Cloud. So yeah, it's definitely something that's in the works. Actually, the interface for offline stores and online stores are both pretty straightforward and simple. We already support Azure File System, so or Blob Store rather. So we already have some support for things around that, but we don't have direct Delta Lake support. And in terms of pricing, we yeah, it's more like talk with us. We can like talk through pricing. It really depends. I can tell you about, but we don't charge you for, you know, like amount of data, because you're hosting your own infrastructure, you're paying for your own storage and infrastructure. So what we're the value we provide is around how many features do you have, how many data scientists do you have. So our pricing is typically correlated to those sorts of things. I can also share that in almost every case, we're cheaper than our competitors because we don't host infrastructure, because we're virtual. We charge you for the things that you're actually using us for, which is, you know, the logistical problems of feature stores. Thanks for the great answers, by the way. Awesome. Any other questions? Does the managed offering include the embedding store? Yeah, great question. So I didn't talk a lot about embedding store here. So one common problem to be solved, and it's becoming more and more relevant, obviously nowadays, is vector search. Embeddings are just becoming such a core piece of machine learning. Ourselves, we have something called Embedding Hub, which is a vector database. We also are partnered with companies like Weaviate and Redis, which also have their own vector databases. Featureform itself, though we have our own offering, we try to be, again, we're virtual. You pick the infrastructure you need. If Embedding Hub is the right fit for you, then yeah, we'll deploy embedding and manage Embedding Hub for you. If you want to use Weaviate, that's fine. Like Weaviate's great, like or Redis or whatever. Like we're partners with them too. What Featureform provides in that realm for Featureform Enterprise is one interface that generalizes it. So you can pick and choose the right vector database for you. And if it's Embedding Hub, we can manage it. If it's Weaviate or something else, they can manage it. We can work together and do a joint solution with them or Redis or whoever. So yeah, great question. Awesome. And Chev, do we have anything coming in through, of course, thank you. Always happy to answer more questions. And you can email me and chat as well, if you'd like. Yeah, is there any questions on LinkedIn or Twitter, Chev?
No, I don't see any.
Cool. Okay, well, I'll give it 1 minute. If someone has that last question they've been thinking of asking but didn't want to ask, like now's the time. If not, then was the session recorded? I joined late. It is, right, Chev? I'm like 99% sure.
Yes, it is. And we'll send like a follow-up email with a link to the recording and some more info.
Yeah, so we'll send a follow-up email with a few things. We'll also send a link to our Slack community, which you can join to learn more and keep up with events we're running. We're running a lot of events this year, both virtual and in person. So it's a great place to keep up with what we're doing, what events we're going to ourselves. Like sometimes it's not even events we're hosting, like we're going to quite a few conferences this year. So yeah, it's a great place to keep up. And obviously it's a great place to ask questions about feature stores or Featureform itself. Awesome. Chev, I'll make you host so you can wrap things up, but I don't see any more questions. There's a lot of great questions. Thank you all for being here. It's pretty much everyone stayed the whole time. So I really appreciate you all taking an hour of your morning with us.
Yeah, thank you all for coming. I'll give it 1 more minute before I close the webinar.
Cool. Awesome. Thank you.